So I'm Paul Merrill. Can we put my slides up, please? Thank you. I'm Paul Merrill from Beaufort Fairmont Automated Testing Services, and we focus on test automation. So we help companies out with problems like, how do we sync up testing and dev in agile environments, right? How do we deal with automated testing, and how do we go back and take regression testing and make it more automated? Those types of questions are the ones that we like to solve. We're very good at it. So if you need any help with those kinds of things, please let me know. Part of my world is I like to have several learning ideas each year. And so last year I focused a lot on test data management, and my two ideas this year were learning about machine learning and how it was going to affect testing. And the second part was service virtualization. And today we're going to get into AI and machine learning, and we're going to talk about that. But as all of you want to know, is it going to take my job? How is it going to affect me as a tester? That's what we want to know, right? So that's what we're going to get into today. And I have to know these things because some of our clients are on the cutting edge of this type of stuff, where they're using machine learning in their products, and we need to know how to test them and how we're going to be affected by them as testers. And I have other clients who don't do that, but I want to know how are we going to be working with this in the future. So here's our agenda. What is machine learning? How will it affect what we test? How will it affect how we test? And then will it take our jobs? Everybody good with that? Good. All right, thanks for being here today. I'm looking forward to this. So number one, I'm not a machine learning expert. So I have to say that because I know some of you in here probably know a whole lot more about machine learning than I do. And you could say, hey, no, you're actually talking about a neural net when you talk about supervised learning, and I won't know the difference, and nobody else in the room will either, but I just want to make sure you know, I know that I'm not an expert at this. But what I wanted to do was I wanted to go back out to the folks in the industry, the ones who were the leaders with machine learning, the ones who were the leaders in AI, and learn from them, because I can't learn what they've learned. They've each sat and worked for 20 years or 30 years in artificial intelligence and machine learning. They know more than I ever could. So why not learn from them? That was my idea. So I went out and kind of surveyed quite a number of folks about how AI is affecting testing, how we're using AI these days, what is machine learning, all these types of things. And I stopped several places along the way as I was learning these things. One was I went out to a site called Weka. If you Google Weka, W-E-K-A. Weka is a site where they have an open source project for machine learning. And it's a UI that comes up. You can download the UI and pull it up and start learning immediately how you take a data set and apply machine learning to it, which types of algorithms do what and whatever. And you can learn with that. The second was a set of YouTube videos, which I'll reference at the end, but this guy worked in finance for a very long time, and he used machine learning from all the way back in the early 2000s, all the way back in the early 2000s, with machine learning up until today, and he just had a ton of information, so make sure to check out the references when we get to the back of this presentation. And you can always get this from me, paul@beaufortfairmont.com. So let's start out with what is machine learning. Who's been exposed to machine learning? All right, how many people could, if I were to ask you, which I'm not, how many people would be able to name one algorithm, one machine learning algorithm or more? Okay, all right. So I would say most of us are novices at this, okay? And that's the way that I'm going to approach this, as a novice to machine learning. So this guy, Arthur Samuel, he's kind of like the godfather of machine learning, okay? A lot of us like to think about computer science and software engineering as being this new world. We think, this industry hasn't been around for a long time. Well, to put things in perspective, I was reading up about him again today, just to make sure that I was refreshed for this presentation. And he put forth a paper in 1959, and that's 1959, starts with the 19, about machine learning and about a program that he wrote to play checkers. And you see him doing that here in the picture. So he put together this program and he said, all right, I've got to make sure that the program understands what a checkerboard is, how you can make the moves, when you need to jump, when you're forced to jump, how to get a king, and all those kinds of things. And he represented that within a computer before 1959 because he published in 1959, right? Now, if you remember your computer science, the Enigma machine and all of that, now all that Alan Turing did was in the late 1930s and the 1940s, right? So only 15, 20 years after the advent of modern computer science, we're doing machine learning. And we've been doing it since 1959 and before. So I just want to put things in perspective. We think about machine learning as being very new. It's actually been around for quite a while. We've only recently started using it within our applications, and it's only recently started becoming more and more available to us. So Arthur Samuel, he had this great idea to put checkers, and what he did with checkers was kind of cool. I actually went out to GitHub, and I've got a reference to this in here as well. But I went out to GitHub and I found a project where they took what he did and where he was teaching a program to play checkers and teaching it to win at checkers with machine learning. And these people have created a representation of that that's out on GitHub, and you can go and play it yourself, which was cool. So I did it like 3 times, and I'm like super serious about it because I don't want to lose to some program at checkers that was written in 1959, right? And so I played it about 3 times and I won each time. I'm like, that's cool, but I did have to think about it. After reading the paper that he wrote, what I realized was that he took a very interesting process to this, and here's how he did it. First of all, he identified certain aspects of checkers as having values. When you're playing a game, for instance, jumping another checker might have a certain value. That might have a high value because we get a positive return out of that, right? If you jump somebody, they take their piece off the board, you have an advantage because you've got more pieces on the board after that point than you had before. Keying someone, that might have a higher value because you can move a king backwards on the board and you've got more moves available to you than other people that aren't kings, right? So he added values to each one of these, and then he put it into basically an equation, and that equation he used in a certain way. And the way that he used it was he took the original program that he wrote to try to do checkers, and he played this algorithm against that, and whether it won or lost, he would take that information and change the values, and the program would actually change the values in that formula to play against that opponent more often, right? So it's this feedback loop. We're feeding in the information that this is how we all learn, right? We get more experience and we learn from it, hopefully. So this is what he did, and he did this, like I said, quite a while ago, and it was very effective. He got to the point where his playing program would actually beat beginners. It was better than beginners. It was like a very good beginner. It worked very well at the beginning of a checkers game. It worked very well at the end of a checkers game, but it didn't work that well in the middle. So it was interesting, and he would have it play beginners and it would beat them sometimes and whatever. But what a great advancement, right? He spent a lot of time on this. That's pretty cool. This is one of the newer kind of people in machine learning. He wrote a book, Tom Mitchell wrote a book back in 1991, I believe, 91 or 97, I can't remember off the top of my head. But this is the way that he explained machine learning. He said that a computer program is said to learn from experience E with respect to some class of tasks T and performance measure P if its performance at task T as measured by P improves with experience E. Basically, does it learn, right? He tried to be objective about it, and he tried to say that, but what he's trying to say is, does it learn? And so he wrote several books about machine learning in the 90s and early 2000s, and he's a very good thinker with regard to machine learning. I wanted to go out and get definitions of these so that we had a starting point. The way that Arthur Samuel says is, he says, machine learning is a subfield of computer science that gives computers the ability to learn without being explicitly programmed. And many of us today think of a program, well, if it's running on a computer, it must have been explicitly programmed that way. That's not what machine learning is. Machine learning is different. There are 3 fields of machine learning, 3 main categories: supervised, unsupervised, and reinforcement learning. We've talked about one of those. It was number 3, reinforcement learning. With the checkers program, we were reinforcing learnings by taking the experiences of the program and returning it back into the program to build that, to reinforce its algorithm, to teach it to do better. The other 2 are a little different, and we use them for different types of problems. The problems that we're trying to solve in supervised learning are of 2 varieties. One is we can categorize things, so we can say this is an apple and that is an orange, right? We categorize them. Or we can give a probability of an outcome. We can say there's a 72% chance that it will rain tomorrow, okay? So those are the 2 types of problems. And we run them over large sets of data. And the reason why machine learning is coming so far to, one of the reasons it's coming so far to the forefront of computer science today and our worlds that we work in every day is because we've got more data than we've ever had. We've got more complex data than we've ever had. We're getting it faster than we've ever gotten it before. To my knowledge, it's faster than we've ever gotten it before in a data processing type of way. And we need a way to learn about that data. We need a way to understand what's going on in it. And we can't think through it anymore. How many people have databases that they don't understand the relationships in? That's a hard question. People don't want to answer that. How many people, let me do it the other way. How many people have a database that they understand all the relationships in? Nobody raises their hand, right? It doesn't happen anymore. These are too complex, these systems. So we're using supervised learning to deal with that data. So we'll take data sets, a large group of data. Let's say it's 1,000 rows. And we'll take the first third of that data with supervised learning, and we'll say, this is our training data. So I'm going to train an algorithm, a well-known algorithm, on how to come out with an outcome. So we've got, for instance, on fruits. Okay, it's this color, it's this size, it's this shape, it's got a stem, it's got seeds, whatever. Those are our categories that we're working on, right? We have these long list of instances of those. So some are apples, some are pears, whatever, and we want the algorithm to figure out what it is. So we give it a third of that 1,000 rows, and we say, okay, learn what an apple looks like with this third. And it says, okay, I kind of got the idea of what's an apple, what's an orange, whatever, because you gave me the answer and I associated the data that's there to try to figure it out. An apple looks like it's red, it's about this big, an orange is orange, right? The second set of data is test data. So we use the second third of that maybe, and we look at what we did with the algorithms. We run the algorithms that we just configured on that second set, and we find out how well does it work. So that test data says, well, we know the answers, right? We know that this row actually is about an apple, and this row down here is about an orange. How often did we get it right? So let's say we get it right 70% of the time. Maybe that's enough for you. If we get it 80% of the time, maybe that's enough for what you're doing, right? Maybe you don't care if something looks like an orange every, 3 out of every 10 times. I don't know. So that's supervised learning. The third set of that data would be your holdout data. So after you think you've got everything perfectly working, you've held this data back, and you'll go back later and actually test with it to see what's going on, okay? So this is a set of data that we're reserving for a final approval of this configuration of this algorithm. The second piece is unsupervised learning. And I don't want to take too much time on this, but unsupervised learning is basically you have a lot of data, you want to know what the correlations are with that data. So we find high correlations between certain fields. Oh, look, there's more water usage on days that it doesn't rain in Atlanta than on days when it does, because people water their yards in the summer, who knows, right? So it finds these correlations for us, and those are interesting. And we talked about number 3, the reinforcement learning, where we have an algorithm that's getting the results from an activity and feeding those results back in so that it can get better. So the types of problems, I wanted to know what types of problems are we using for machine learning today, where is machine learning today, and where is it going tomorrow? So one of the first ones that when I talked to people that they came up with was natural language processing. So if you remember your computer science, natural language is English or Chinese or Spanish or German or whatever these languages are. We need to process those. Well, why? Because we've had quantifiable data, and that's terrific, where we have numbers representing things within our databases. But now we're starting to do all these crazy searches. People all over the world are searching our websites for things. They're putting data into systems where, doctors are putting data into medical systems. We need to be able to take their notes and understand exactly what they're trying to say. So we want to take that qualitative data and turn it into more quantitative data if we can, so that we can search on it and do different types of algorithms on them. Healthcare is huge. Imaging is huge. So imaging is a major one, and that I'll talk about a little bit in a couple minutes here. But the idea of how we can look at things, and you and I, we look out at the world and we see edges to certain things. Computers can't do that. In fact, finding where one object in an image starts and where another object begins for computers is incredibly hard. And what I learned in doing this experience, in going out and finding people who have the experience with machine learning, is that there's actually a part of your brain that processes that before it gets to the conscious level. It's built into our brains, it's built into mammals' brains, it's built into animal brains to be able to process edges. Computers don't know that. It's been a very difficult problem to solve. And I'm going to talk to you about somebody who's doing that right now with imaging. Transportation is a big thing. We see AI driving cars driving themselves. Search was huge. You guys see Google get better over the last 20 years, 15 years? How long has it been around? 15 years maybe? It's gotten better and better over time. Where are we using machine language? So we're dealing with large amounts of data. We're augmenting human judgment. That sounds a little bit scary for some of those folks who put the matrix up there maybe, but augmenting human judgment, so finding a way to add to the way that we judge things, finding ways to add to how we think through problems. We're using it all over is actually what's happening right now. How will ML affect what we test? And this is where we get into some of my reading. So I don't love reading these reports. but I do because I feel like I have to. I want to know what World and Quality Report comes up with. This comes out from a few major vendors in the testing industry and the computer industry in general. HP is a part of it, Capgemini and Sogeti, if I said that right, Sogeti, are all involved there. But they say in this report for this past year, we believe that the most important solution to overcome increasing QA and testing challenges will be the emerging introduction of machine-based intelligence. Anybody nervous about that? No? Some of us maybe a little bit? What are they trying to say here? What's going on? How can machine learning take over what we do as testers? What we're going to test is going to change with machine learning. So one of the things that I told you about is the idea that we get these machine learning algorithms running, we configure them, we get to a point where we realize, hey, this works 80% of the time. Hey, this works 90% of the time. How do you test that? Up until this point, we've had deterministic things, right? And this is deterministic, it's just on a very large scale, so it's very difficult to think through, right? But we've always been able to say, this answer is right, that answer is wrong, and I can verify if the system works because I know I should always get a right or I should always get a wrong with whatever it is we're testing. We can verify it. When the problems get more difficult, we start to use machine learning to figure them out for us because we can't figure them out ourselves for whatever reason. We need their help. So this gets much, much more difficult. The expectations for systems become less clear. The tolerance for error becomes greater than 0. When you have an algorithm that does the right thing for you 80% of the time, and that's as good as you can get, we want to test to make sure it did as good as it gets, right? But then it brings in all these other questions. What happens in a case where you're 80% of the time, you know your algorithm is going to be right? If you run tests 1,000 times or 10,000 times or 1,000,000 times, and 21% of the time it's wrong, does that mean the algorithm's wrong? Or does it mean your test is wrong? Or did you just not run it enough times, right? So there's lots of different questions that come up with how we're going to test these types of things. There's going to be less repeatability. One of the big things there is if you're running these particular algorithms, if you're inside machine learning and doing that with your product, you're doing it because you have complex data already. You have complex data because you're probably getting it really fast. When you get that data really fast, it changes really fast over time. How many people have systems that they work on today where they can't go back and get the data to a state that it was yesterday? You can't go back and get data to a state that it was yesterday. I think that's underrepresented. Okay, all right, fair enough. That's what you say. That's the set of data. There are a lot of systems now that are that way. You think about logs that have to be kept and cannot be deleted from a system. Anybody have that situation? How are you going to go back if you got test automation that's creating logs, creates 1,000 log entries, and you can't delete them, but you want to go back and test whether or not logging worked? You want to run the same test that you ran yesterday today? You got a problem, right? So data's changing a lot over time, and we're using these algorithms to try to deal with them, but we're going to get less repeatability because the data is going to keep changing over time. It's going to keep coming to us. It's streamed to us. I've talked about these others as well. So, but the expectations become less clear, and that makes our job much more difficult. One of the people that I talked to, I'm from North Carolina. So in the research triangle there, the research triangle is made up of 3 large institutions. So NC State University, North Carolina at Chapel Hill, and then also Duke University. And right in there we have some really great companies that are starting up or in different places. We have all the major representatives from all the big companies there. But one of the ones that's starting up there is called Precision Lender. And what they do is they help loan officers make better loans. So if you're at a bank, if you work at a bank and you can offer loans to people, the way that you've done it in the past is to sit down and say to someone, hey, what's the price of this loan today? What's the interest of this loan today? How do I set up a loan today? And that person either knew how to do it, or what was more often, they would look around the industry and see what anybody else was charging today for a loan of that particular type. They may be following people that didn't know what they were doing, or they might have been following people who did. Nobody really knew. Somehow we got by. But today, what they're doing at Precision Lender is making it so that that officer can plug in what the person buying the loan wants and change the options on it and determine whether or not that bank will still make money from that loan in real time while they're sitting there. It's pretty cool stuff. And it's benefiting banks a lot. They're using machine learning to move this along. George Neal is their chief data analyst, and we had coffee one morning. And I said, tell me about what we test and how that's going to change. He's a machine learning expert. When you see data analyst, that's what that means. It means they do machine learning all day, right? So he does that all day long. He's done it for years and years and years, and he says testing is going to get harder, just like I talked about before. And he says, for people who don't like to do what humans do well, the future is a very scary place. I said, George, what's this going to look like? How are things going to change? And he says, well, if you want to drive a bus and make the same route every day, sorry, that's going to be gone, right? Because we've got computers that can do that. If you like to do judgment, if you like to do analysis, the things that we do every day, if you like doing those things, the future looks really bright for you. It's just going to get a lot harder, a lot harder. So the future could be a very scary place for some folks. How will machine learning affect how we test? We talked a little bit about this already. But here's a different example. When I first thought about doing this talk, I was out at Star West in California, and I sat down at a thing like this. There were 300 people in a room listening to this panel of executives within the IT industry. And these executives were sitting up there, and the first one answered some question about machine learning and how it was going to affect us all, and he says, yeah, it's going to take a lot of testing jobs. I thought that's the stupidest thing he could possibly say. Because he's sitting in front of a bunch of testers. He's got 300 testers in front of him, and he just told them all they're going to lose their jobs. That's stupid, right? Like, why would you do that to people? And then the second person standing there, he answers the same question and follows the lead of the first one, and all 5 of them in a row answered exactly the same way. And I don't know about you, but anytime I hear 5 executives agree in unison, I have a problem with that. I want to know what's going on, okay? So I took the idea back to the head of the conference and talked to him about it. Hey, I want to understand, are they right? Is machine learning going to take all these testers' jobs? He says, you need to talk to Jason Arbin. So Jason Arbin, among other things, wrote a book called How We Test Software at Google. Very good book. He wrote it with another person as well, but he was a co-author on it. And when he got done with that book and several other things and working at Google and whatever, he started this little company called AppTip out in California. And what AppTip does is it takes a mobile application and it uses machine learning to go through all the functionality and figure out all the functionality of that mobile app to figure out what inputs should go into it, what the output should look like, whether or not there's a bug in there. The likelihood of them finding a bug is high. And what's really interesting about this is that they do it in a pricing model that's much cheaper than you and I as testers, right? Much cheaper than our salaries. So it might be $50,000 a year in the Bay Area, and without benefits, of course. That's much lower than most testers in that area would get paid. But what's even cooler to me in a technical perspective is that when folks come in as clients and they sit down with the AppTip team, they come in with their mobile app and they're like, look, this is our mobile app. It's out in the Google Play Store. We love it. Show us how your product is going to test this thing. We want to see this work. And they say, well, put that down. We know about your app. We don't have to know, don't explain it to us. We don't care about all that. Because frankly, we've already downloaded every app off of the Google Play Store and every one off of iTunes and everywhere else. And we've already run all of our algorithms against them. And here's the results for yours. We noticed that between versions 2.1 and 2.2, there was a change to this part of the application. We identified that as potentially being a significant defect that you would want to fix. In 2.3, you fixed it. And they're blown away, of course. Who wouldn't be? And I said, well, Jason, this really brings up some questions for me because as a tester, I want to make sure that we keep doing this. This is cool stuff. I like testing. He says, here's the thing. Machines are better at programming than they are at testing. Right? How many times as a software engineer, did I sit down and use something that generated boilerplate code? And it did it pretty well. You can generate code with code pretty easily. It's not that big a deal to do. But he says testing is much harder than that. And he went on to say this, which I really like this quote. He says, you have to be smarter than most programmers to be a really good tester. And I'm like, that's cool, Jason. Say more stuff like that, right? So as a tester, I love hearing that. But as a programmer, I'm a little skeptical. I don't know if that's right or not. I like the statement. I'd love to see how you guys think about it later. He says, I still think the hardest thing in software is testing. And this is somebody who can do development, someone who's been at Google, someone who's been across the board, he's written books on testing, and he says, I still think the hardest thing to do in software is testing. I'm like, that's cool, I like hearing that too. He said, when computers generate code, they don't test it either, right? A developer, how often do your developers test their own code? Lots of them. I do that when I'm developing now, but it's because I have a testing mindset, right? I try to, but it's hard to put on one hat and switch the other. It's difficult sometimes. And then I talked to some other folks. So Jason was a really great interview. The guy talks a mile a minute. I could barely keep up with him. He must drink like 10 Monster energy drinks, every day before noon or something. But terrific guy, I really appreciate it. I had several other conversations with folks, and we found out later on that their companies would not allow them to be named in these things. But what I will tell you is that all the ones that say anonymous are coming from a major healthcare company that does analytics and focuses a lot on machine learning. And the people who are anonymous in this spent a lot of time with those machine learning algorithms, testing them and whatnot. So this person says, machine learning will augment our ability to be extremely smart about what we cover. I like that idea, right? How many people know what test coverage is? That's better than me. I'm not sure what it is anymore. I talk to people, and I talk to my clients, so I sit down with clients and I want to know, what is it that you do right now for testing? Why do you do it? What are we going to try to accomplish with testing? Why are you trying to do test automation? Help me understand your intention with this, and I can help you get to your goal, right? But the number of times that we sit down and we talk about test coverage, or that I sit in the testers.io Slack channel or get on Twitter or whatever, and someone brings up the conversation of test coverage, I've gotten to the point where I'm not sure what it is. I know what code coverage is, I know what branch coverage is, and I'm not necessarily talking about one of those as being greater than another, but I know what those are. I can define them with real terms. But talking about what we're going to cover, I think of what this individual said in terms of code coverage. We're going to be able to cover more of the code with machine learning more easily, or be smarter about how we do it. She says machine learning will work from within the program, informing us of what to test. That sounds cool. You guys remember the IBM commercials where the server figured out what was wrong with itself and fixed it? Yeah, does that work? Do you guys use that feature right now? I love IBM, but I don't know what happened to the feature. It was a cool commercial though. So we're getting there. We're getting there, right? This is Doug Kubel, and he is a VP of Product Development at Ultralink, another company that's based up in the Triangle, where I'm from. And Doug has been working in machine learning for a long time, and the product that they're working on is pretty cool. So we had lunch one day, and what Doug was telling me was that within the healthcare world, there are a lot of problems around imaging. And the problems that we're dealing with imaging right now are problems such as taking ultrasounds of the human heart in order to understand how much blood flow is going through different chambers of the heart. And this is important I'm not a cardiologist, I don't know why this is, it's important, right? We all want lots of blood going through our heart, I guess, okay? So they are looking at that problem, and the way that it's dealt with right now is the doctors and I guess the sonographers will take ultrasounds of the heart from one area, from this angle, and then they'll take another one from this angle, and because they've got the two different angles, they can look at it more two-dimensionally or three-dimensionally, I guess, three-dimensionally, and they can kind of get an idea. But the way that they predict how much blood is going through is a doctor takes each one of those images that are done throughout the day and spends between 30 seconds and 2 minutes looking at them, watches the video of it, and determines, oh, that's 25%, oh, that's 50%, oh, that's 70%. So if you can think of a doctor spending that much time on that as opposed to working on people, that's a big problem that we could solve with machine learning, right? All we have to do is identify within those images where the boundaries of the heart is. It shouldn't be that hard. But this is what they're trying to deal with, and it comes back to that idea of seeing edges within images. So what they have to do is locate with machine learning where the edges of the chambers of the heart are within each image, and then they can use that to calculate the amount of blood going through the heart. He told me about some other things that are pretty cool that are going on in healthcare. So it's been a long time since this happened, but we're to the point where we can recognize tumors in lungs in images with machine learning. It's pretty cool that a computer can figure that out with us. With a high degree of success, we can do that. We can do it within kidneys, where there are problems in kidneys. We can see that with machine learning these days, where there are objects in there. So he taught me a lot about that, but basically what he was saying is there's this entire set of problems that have required human judgment that are now tractable. And I had to go look up Tractable because I'm just not that smart, I guess. But Tractable means it's something that we can handle, something that we can deal with. So Doug says, I asked him about the future and what was going to happen with the future. And he says, machine learning may enable some types of testing, maybe new types of testing. It'll enable some of what we do already. But what I really want to know with all of this, and what you guys probably want to know as well, is this going to take our jobs? So in talking to Jason Arbin from AppTip, one of the ideas that he shared with me when I asked him, I said, Jason, tell me how what you're doing at AppTip compares to humans doing testing work. And he says, well, here's the thing. Most of the time what we're finding is that we find about 90% of the defects that could be found in the application at any time. I'm not sure how he measures this, but he said we find about 90% of what's out there. He says the best companies out there with the highest talent that wants to work hard, that wants to understand problems, and that looks deeply into it, usually only gets 90%. It's very, very few companies out there who spend the money and spend the time and spend the labor and spend the education on people to get them to the point where they're looking at the other 10% of that problem. Those really difficult bugs that are hard to find, that are hard to understand, that are hard to talk about. We already take care of 90% of them. And most companies only take care of 90% themselves. Anybody else starting to get a little scared? He talked about testers with big T's versus testers with little t's, and I don't know where exactly this concept came from. It is not mine. I'd like to reference it. If you know, please tweet it to me or send it to me in an email at paul@beaufortfairmont.com. But the idea of a big T tester, someone who takes this seriously, looks at this as a craft, studies it day in, day out, and wants to do testing really, really well. The other type of tester might follow scripts all day long or do something other than the other part. But most testers are in this lowercase t testers. He says there's no way, a friend of mine, this anonymous friend of mine said, there's no way machine learning will be involved in every single testing job in the next 30 years. Okay, that's fair. Like I look at the progress of Agile, all right? So Agile, the manifesto was written in 1999. And we're still having trouble adopting it today, 18 years later. I see companies almost every day almost. So I talk to multiple companies throughout the week, leads that come in, new clients. The reason why I've given you this form is because I want to get to know you and I want to talk about what it is you do and how you work. So please fill that out when you have a minute. But I like talking to folks like yourselves and understanding what's going on in your testing environment. How are you doing test automation? What's working for you and what's not working for you? And what I find over time is that we're still struggling to adopt Agile. We're still struggling to figure out how to do test automation. And we were doing this well in plenty of cases long ago in 2002. There were people doing this long before that. So the authors of the Agile Manifesto, they didn't come up with it when they met in Colorado or wherever it was that year, right? They've been working for 20 years in software to figure out how to do that. So these processes are not new. They come out of experience that's been painful to get. And adoption of machine learning will be much the same, right? We'll have some companies that are at the front of that adoption and some companies that are at the back. Deep learning won't put everyone out of a job, but it will have an impact. Okay, fair enough. Doug said that. I thought that was a pretty good statement. It won't put all software developers or testers out of jobs. Okay, fair enough. And I asked Jason, I said, when I asked him, will machine learning replace testers? He just said no. He didn't have anything else to say about it, no. I love Jason's faith in us. I think that's cool. But there are a lot of problems here. There are a lot of things that are going on. There's a lot of testing that's going to change dramatically. Machine learning is going to keep moving forward. AI is going to keep moving forward. They're going to solve more and more problems. I saw a study where they were talking about transportation and how the transportation industry would be affected by AI, by self-driving cars. Transportation accounts for 16% of the jobs in the United States. Even over a 30-year period, 16% of jobs in the United States going away is a significant change. Very significant change, right? Think about all those other things, the imaging. How many jobs would go away with relationship to imaging? How many in the healthcare field would go away? And all these things they're not going to be done one after the other in sequence. They're going to be done in parallel, and they will all grow quicker and quicker over time. So when we're looking at the future, I think it's a little bit silly for us to think as testers just because we have to think about what we do, just because we have to be analytical, that we won't be challenged, that a lot of us sitting here won't be challenged by machines doing this work. And when I went to talk about this, when I started thinking about it, what I really wanted to come back to you guys with was the idea, no, machine learning won't come, it won't take your job. And I wanted us all to be happy afterwards and have these warm fuzzies and everybody could sing Kumbaya and everything together. But then what I realized is that I would be doing you a disservice if I were to lie to you about it. So my belief is that things are going to change. They're going to change significantly. I'm not saying that all tester jobs will go away, but I'm saying that some will. And we will change the way that we do testing because of it. And the only way that you're going to keep up is with what's in here, your gray matter. Are you forcing updates on your gray matter? Are you working ahead? Are you pushing yourself towards what's great, what can be great for your company with regard to testing? What are you doing with that? How are you getting that gray matter upgraded? So in the end, I ask you one question. Machines are learning. Are you? That's all I got. I'm Paul. These are my references. I'm happy to. I was.
Thanks, Paul. We got a couple questions in on the Poll EV app. Again, if you want to ask Paul a question, we maybe will take some hand raisers too. But first one, do you see machine learning being offered as a third-party open source approach to testing, or will it need to be built out in-house per company?
It's already being done multiple ways. So this is a great question. I love the questions. Please feel free to ask them. And by the way, I'll make myself available after this outside of the room for any questions about this or test automation or whatever else. I really want to learn more about your systems and what you're doing. But machine learning in general right now, there are plenty of open source tools out there to use it. Most of the major algorithms that have been known for years and years and years have been made in Java and in Python and everything else, all the other great languages out there. So it's already available that way. Over time, what I see happening right now is that we're adding microservices to do some of these functions. We're making them more available from third parties and across the world. So yeah, I mean, I think both is the answer there. I mean, I'm not an expert though, so somebody else can tell me. I have a question back here.
Audience question over here.
Hiya. I want to put something onto the table about the nature of learning itself. And ask this, do machines ever actually learn? Certainly they refine their algorithms, but can they do that without help from people in society? For instance, the United Airlines debacle last week, that happened as a result of what's really effectively an algorithm, a policy at United Airlines that says, well, this is what happens when we need to get 4 people to Louisville. We throw a paying passenger off the plane. I think we could say that the people who were involved with that decision learned something. However, the algorithm is still there, such that this week, a couple of days ago, a 10-year-old kid flying back from Florida, I think, to somewhere in Canada, on an Air Canada plane, got told that he could not board, although his parents could. Now, it seems to me that a check-in attendant at an airline would think back to this thing that happened last week with United Airlines, but the algorithm did not do that.
Right, yeah, but would they too is the other question. So I'm interrupting you.
No, you're not. You're now chatting. That's good.
So number one, this is Michael Bolton, and he's doing the closing keynote tomorrow, and make sure absolutely to see his talk because I'm sure it's going to be amazing. And if you don't know who he is, look him up.
Thank you.
He's done huge things for the testing industry, and many of us owe a great debt of gratitude to him for what he and his cohorts have done. Thank you very much. And this is my first question from him ever, so I'm a little nervous. So can machines truly learn? I don't know. But I do have a couple questions to go along with that with regard to, my first was, are the people going to learn from that? And I think we've gotten to a different place in society than we have been in the past. The place that we are today is the computer won't let me do that. right? How often do we hear the computer won't let me do that? Lots now. It used to be the computer won't do that. And before that, it was I don't know how to use the computer to do that, right? But we've got a lot of other things going on too, Michael. So how many of us have a Fitbit on that tells us when to get up and walk around? Really? Computers are going to tell us when to move? Computers are going to start telling us how to do our jobs. They're going to start spitting out scripts to do your job more effectively. All right, fine, but
All right, last question that came in, Paul.
it's a good question. I don't know what the answer is. I think that we all have to start learning more and get back to the learning that we were doing before all of this, and I think that we need more people who are focused on doing real human learning in order to work with this artificial learning. Does that?
Well done. Last question, favorite college in RTP?
Oh my goodness. Okay. This is difficult. So this is like a blood feud up there, if you guys don't know, with basketball. Duke, Carolina, NC State, they've all got national championships. One of them just got one. So I moved from Florida. I went to Florida State. So you know, there you go. You know where my allegiance is. But I have a lot of family members who went to State. It's a great school, good for computer science. Carolina, I have some very good friends from there, although their fans are really rowdy and obnoxious. The Dukies are cool. I have several friends who went to their business school. I love talking to them and getting to know them. So I'll just be very
Way to be Switzerland, man. Just
yeah, I'm gonna be
staying totally neutral.
Yeah.
Good job.
Thank you.
Everyone, one more time, Paul Merrill.
Thank you. And if you'll